So imagine this, right? You want to compare between the grades of two different classes. And let's say both classes have the same mean score. So for example, class A, class B. You want to compare their math grades. Okay, and let's say in class A, everyone scores a score of, let's say, 50, 50, 50, 50, 50, and 50. Now for class B, not everyone scores 50, but at the core of it, the mean score is still 50. So for example, for class B, we can have a situation of, let's say, 25, 75, 0 as well as 100, right? Now the question is, even though both of them have the same mean score of 50, is it right for us to say that both classes have the same performance? That is absolutely not true, because for class A, you can see that everyone scored 50, whereas for class B, we even got a 0, right, out of 100, and then someone even scored full marks over here. So just comparing the central tendency is not enough, because we will need to take into account the variation as well between the different data values over here, right? So just note that all of these over here are my exact data values, right? They are all just exact data values, and therefore this one will be our experimental approach, right? We are just approaching this through the lens of an experiment. But later on, similar to expectation in the previous section, there's a theoretical approach as well to this. But we need to go through the experimental approach first, which is what you have already learned. So the question now begs, right? Since the X bar or the mean score is the same for class A and B, how to compare their performance? Then that is where we need to measure the variability of the results instead, right? And then as we can see over here, for class A, everyone is very consistent, right? And then for class B, it's less consistent, right? There's more variability. So the whole idea behind this is to calculate the variance, right? In other words, it's a concept that you already know, which is your standard deviation. So when we say measure the variability of the results instead, so I'm just going to write this properly, results instead, this variability is what we call the variance, right? So this one is your first key term that you need to know, right? And what is variance essentially? Variance, the definition, but you don't need to memorize this definition, but I find it easier to first define it so that you get a mental picture of what it is, right? Is the average squared difference each value and the mean. Okay, so I'm going to paint a picture over here to show you what variance is, okay? And it's going to be, because writing this out over here, you might not really grasp the idea, but when I draw it out, it'll make so much more sense for you over here, right? So let's just draw this out. So you just imagine this, right? We're just going to use the example from earlier on, and that is, let's say I have a center line over here, okay? And imagine this center line is the mean value. So the mean value is 50, right? If all the values 1, 2, 3, 4, 5. If they all lie on the mean value line, right, the effective distance is 0, right? Because all of them literally 50. But then let's say I have another one over here. I'm just going to draw another line down here. And then let's say this is mean is 50. So we know that for the values, previously we have 1 here, 1 here, 1 here, 1 here, and 1 here. So there are distance, right? There's a distance between these values and the mean value of 50. So that is what we call the difference, right? The difference is basically the distance between the value and the mean value. Now, why do we square it? So squaring it is, there's actually no logical reason behind it. Okay, I mean, there is a logical reason, but it won't come to your mind straight away, right? And that's simply because when we measure distance, right, assuming this over here, I mean, this is the center line, right? The distance behind this will be negative, right? This is negative distance, or rather negative displacement. You can think of it that way. And then this is positive, this is positive. But of course, when we want to measure the magnitude or the magnitude of the difference, we will want all values to be positive, because if we have a negative and a positive, they will cancel each other out, right? And then when they cancel each other out, then that is where we get a inaccurate reading, because when they cancel each other out, it gives us the impression that, hey, there's no difference between the values and the mean value. But that's certainly not the case, right? So squaring it is actually just a practice, like just standard practice. So I'm just going to write here, to get rid of the negatives and make sure that all values are positive. So let's say I take this as distance 1, distance 2, distance 3, and then last but not least over here, I have distance 4, right? So in order for me to calculate the variance of this, right? So let's just call this, I call it distance 1, distance 2, right? Then I'm just going to call this C1, C2, C3, C4, C5. Okay, and then I'm just going to call this distance 3, distance 4, distance 5. Okay, so for this over here, right, we can see that the distance is 0. And how do we actually calculate the distance? What we do is that we take the mean value of 50 minus the 50, right? We minus each individual value, so minus 50, and then we square it, right? And then over here would be 50 minus 50, and then we square it. And then of course we repeat, right? 50 minus 50 minus 50, we square it. 50 minus 50, we square it. 50 minus 50, we square it. Because we take 50 minus 50, mean value minus actual value of 50, and then we square it to get rid of any negative if there is, right? But even if it's positive, we just square it as standard practice. Then we divide this whole thing over here by 5 because we want to find the average squared difference. And then in the end, we get a variance of 0, right? So this is the variance. So for the first data set, the variance is 0. But for the second data set, the variance is definitely not 0, right? Because for the variance of this, we essentially will get a value of, for the first data, will be 50 minus 0, and then we square it, right? And then for the second one, it'll be 50 minus 25, and then we square it. And then for the third one, we have 50 minus 50, and then we square it. And then for the fourth one, we get 50 minus 75, and then we square it. And then the next one, we get 50 minus 100, we square it, right? You realize that if we don't square this over here, and if we don't square this over here, this comes out to be negative 25, this comes out to be negative 50, and this negative 50 will actually cancel out the positive 50 over here, right? And then this negative 25 will cancel out this positive 25 over here, right? Which, if we don't square it, it seems like only this is left, but we know that that's not the case, right? So we have to always square it. And then this whole thing, we divide by 5 because we want to find the average value, okay? And we will actually get a value of 1250, right? After we divide by 5, we get the value of 1250. So you can see that variance over here is 1250. So you can think of variance as a score, right? The larger the variance means there is more variability. So you can see that even though these two data sets, they have the same mean, but the variance is very, very different from each other. Okay, so this is the concept of variance, and I hope that I explain it in a way that is easy and intuitive for you to understand. And then of course, you might be thinking, how does the concept of standard deviation actually come into play over here, right? So after we calculate the variance, so let's say the variance is a value of A, then the standard deviation would be square root of A, right? We just square root this. And why do we square root it? Because earlier on, we actually square it, right? We actually squared it at the start to get rid of all the negative signs. But the downside of squaring it to get rid of all the negative signs is that we blow up the values. We exaggerate the difference. So the side effect of this is that we exaggerate the difference. Because if the original difference is, let's say, like 5, right? By squaring it, we blow it up and then we exaggerate it to become a score of 25. So but we have to do this because we need to get rid of the negative sign. So after we do it and then we get the final variance score, we then reverse the effect of squaring it to boil it down to the true score, right? The true score in that sense. And that's the standard deviation. So we square root it to remove the exaggeration. Okay, you can just think of it that way. All right. And that's the whole idea behind it. So if I could give you a formula to wrap up this fundamental concept, the sample variance, the formula is just the sum, right? The sum of what? The sum of all the individual values minus the mean, right? So you have all your individual values and then you minus away the mean score, right? And then you square it over here. Okay, so just take note that you sum all the individual values and then you minus away the mean score over there, right? And then you divide by the number of values. So that's basically how you calculate sample variance, right? At the end of the day, the key thing to note here is that we are measuring it against the mean value. You're just measuring it against the mean value. And that's why the formula over here is you take all the individual values of x, right? You minus it against the mean value. So you minus already, you get difference, you square it, and then you sum all of them together, then you divide by the number of values to find the average value. Alright, so that's the whole idea behind variance over here. So that is actually what I'm going to go through in the next concept over here, which is the variance of a discrete random variable. But this, and there'll be more formulas over there, but this is the idea behind it in the experimental approach. Okay, so let me know if you got any other questions in the comments below. If not, this is the introduction to variance, which I will personalize towards this chapter in the next video, and I'll see you over there if you have no other questions. There's no practice questions for here, so I'll just see you in the next one.